In class recently, we have been working with solving single and multi-step linear equations, so I just wanted to make another video to kind of walk you guys through the steps. I've written the steps over here on the right side. Steps number 1 and 2 kind of go together. The first thing I like to look at, if necessary, get all the x's on one side. Sometimes you may have a problem where the x is all by itself, and you need to go on to step 2 and get all the numbers on the opposite side. So it really depends on what the problem looks like. The problems I have over here both have x on a side with the numbers. So the first thing we're going to do is try to isolate that x by, in this situation, getting rid of the 2. So since that's a positive 2, the way to get rid of that is going to be to subtract 2 from this side, which is going to give me 0. And because of the property of equality, if I take 2 away from the left side, I have to do the same thing to the right. So 11 minus 2 is going to be 9. And when I rewrite the equation, since I took the 2 away, I have no numbers by themselves, so I'm going to start out with that 3x. And on the other side of the equation, I just have that 9. So I've kind of undone what we like to think of as the addition or subtraction parts. Now I'm left with the 3 times x on one side and the 9 on the other side. So I know that in order to get rid of this 3 times x, I have to do the opposite of multiplication. I'm going to divide. And again, I want to get the x all by itself, so I'm going to divide it by 3. And if I do that to the left side, I have to do the same thing to the right side. So I know that 3 divided by 3 is 1. And that leaves me with just the x all by itself, because 1 times x is going to be whatever x is. And 9 divided by 3 is 3. So there's solving for x. Step number 3 is important. We want to take that x that we came up with and plug it back into the problem and check to see whether or not it's true. So I'll change the color up here. I still got that 2 plus the 3, and then I said that the x value is 3 equals 11. Everything on the left side of the equal sign has to be of the same value as that 11 on the right side. So I'm going to double check that. I know that 3 times 3 is 9. So my new equation is 2 plus 9 equals 11. And then I just need to check to see whether or not this is a true statement. 2 plus 9 is 11, so I know that that statement right there is a true statement, which means that 3 is the only possible solution for this particular problem. So what I'd like you to do right now is go ahead and pause the video, work your way through the second problem, and see if you come up with the same answer that I have. Okay, now that you've had a chance to work your way through that problem, let's go ahead and use the same directions we did before. I want to isolate that x, so I'm going to get rid of this positive 5 by subtracting 5. And I'm going to do the same thing on the right side. And that's going to leave me with 20. So my new equation is 4x equals 20. If you need a few moments to go ahead and pause it right now. Okay, since I already undid the addition up here, I'm going to go ahead and try to get rid of this division. So I have to ask myself, what times 4 will give me 20? To undo that multiplication, I'm going to divide by 4. 4 divided by 4 is 1, which gives me just x. 20 divided by 4 gives me 5. So let's go ahead and plug that back in now and see if we're correct. 4 times 5 plus 5 equals 25. I know that 4 times 5 is 20. So I just need to see whether or not this is a true statement or not. So 20 plus 5 does equal 25. Therefore, that's the correct statement. I'm going to go ahead now and move on to another page here with multi-step equation. In this situation, it's the same steps. Get all the x's on one side, get all the numbers on the other side. And again, I like to make sure that each of the x's are positive. It just makes it easier for you to solve the problem. So I'm going to start with the x's. And I know over here I have a 3x, a positive 3x, and over here I have a positive 5x. So I'm going to want to get rid of this 3x because that will ensure that my x is positive over there. So to undo that plus 3x, I'm going to subtract 3x, which leaves me with no x's over here. And since I subtracted 3x from the left side, I need to do the same thing to the right side, which leaves me with 2x. So my new equation is a negative 2 is equal to 10 plus 2x. So now I need to move on to step number 2 because I have no x's on the left side. All of my x's are isolated on the right side. So now I need to get rid of this positive 10. To undo that, I'm going to subtract 10, which leaves me 0 over here. And if I do it to the left side, I have to do the same thing to the right side. So a negative 2 minus 10. Going back to my rules of arithmetic there, if I'm subtracting, or if I'm combining two negative numbers, since the signs are the same, I just add the two numbers together and keep the sign. So a negative 2 and a negative 10, I know 10 plus 2 is 12. And since they're both negative, it's a negative 12. So my new problem right here is going to be negative 12 equals 2x. And now I need to undo this multiplication. So I'm going to divide both sides by 2. And 2 divided by 2 is 1. So x equals, well, a negative 12 divided by 2 is a negative 6, because 12 divided by 2 is 6, and since the signs are the opposite, it's going to be a negative. Now I need to double check my answer up here. So a negative 2 plus 3 times negative 6 is equal to 10 plus 5 times negative 6. I know that a positive 3 times a negative 6 is going to give me a negative 18. And over here, I know that a positive 5 times a negative 6 is going to give me a negative 30. So a negative 2 plus a negative 18, since the signs are the same, I just add the 2. 2 plus 18 is 20. And again, since the signs are the same, it stays with the answer. On the other side, I've got a positive 10 plus a negative 30. Since the signs are different, I'm going to look at the largest absolute value, which is 30, and I'm going to subtract the 10 from 30, which gives me 20. And since the 30 had the largest absolute value, I keep that sign. So seeing as how a negative 20 equals a negative 20, I know that the answer of x equals negative 6 that I had over on the left side is the only possible solution for that problem. So as you can see, the steps are basically the same as what we did with the single step equations. We just had to do this, isolating the x's and isolating the numbers. So it's not like it's a different type of problem. We just have to make sure that we include both of those steps. So hopefully this has helped you. If you have any more questions, again, please check in on the Schoology page, or by all means ask in class.